Over the course of the last 4 videos, we've outlined the full capability of your Omnia II instrument. In this final video, video number 5 in the Omnia II video series, we're going to show you what not to do with the instrument. Despite a robust industrial build, it is still possible to damage the instrument if used improperly. We're going to show you how to avoid this to get the maximum capability out of your instrument. One of the most frequent causes of damage to Associated Research Inc. instruments, including the Omnia series, is due to improper test station setup. We've determined that in many instances, test operators mistakenly allow high fault currents to feed back through the return input of their device. This causes damage to sensitive components and PCB traces. Fortunately, it's very easy to prevent this type of damage to your instrument by taking some simple considerations into account prior to testing. The first consideration is very simple. To ensure that current isn't improperly being fed to the return, what we always recommend is that you run your high pot test prior to running your line leakage test. For example, I have a mock test set up right here, and we can see I have my high pot test first and my line leakage tests after that. This ensures that if something happens with the high pot test and the product installation fails, you're not then going to go and run the line leakage test. The second consideration is to utilize the fail stop feature. As we discussed in a prior video, with fail stop on, the test sequence will stop upon a failure. So if your high pot test fails, this means it's not going to continue on to the line leakage tests. What I've done here is I've actually shorted my high voltage in return to purposely cause a fail, and I've turned fail stop off to look at more of a worst case scenario. As you can see here, it continued directly onto the line leakage tests. And this is not the most optimal case, because if the high pot test fails, you may not want to run the other tests. By turning fail stop on, the sequence will stop, and the operator has to push the reset button to continue and run the sequence again. The third recommendation is to always remove the test leads from the DUT prior to running any other tests. Let's run through a quick example. As you can see here, I have the Omnia connected up to a product. I have the high current lead connected to the ground pin for a ground bond test, the high voltage lead connected to the mains input for the high pot test, and then of course I have my return on the chassis. Say this sequence was done, and the operator then needed to connect it to an AC power supply for a run test. If the operator removed the leads, and then went on to plug it into the power supply, but left the return lead on, there's the possibility that if something goes wrong during the run test, current could make its way back to the return and damage the instrument. Always remove all leads from the Omnia before moving on to another test station. The final recommendation we're going to make here comes into play if you have an 8206, 56, 07, or 57 instrument. That's because those instruments have what we call the LLT card for line leakage and functional run connection. The advantage of this card on these DUT outputs is that it allows you to run the full gamut of testing from just these connections: line, neutral, case, and ground. For example, you can see here that I have a product connected up to the adapter box. So line, neutral, and ground go to the adapter box where I have the product plugged in. Case is my return point, which I have on the chassis. The advantage of using case over the front and rear panel return is that when the functional run or line leakage test starts, there's a relay internal to case that opens, isolating the return circuit so that no damage can be caused. This concludes the Omnia II video series. Although we've covered a great deal of information, we've really only scratched the surface of electrical safety testing. It's highly recommended you visit our website for more information. Thank you.